Two addendums on the last partial pressure thing. It was correct. I'm just going over some specifics. Since we went for the hydrogen from a 5-liter system to a 7.5 liter, that means volume went up. We can always expect pressure to go down. So if you got a bigger pressure than you started with, you made a mistake. So we can see the initial pressure of hydrogen was 85 and it went down to 68. Notice that the initial pressure of nitrogen, oh no, that was the initial pressure of nitrogen, 85, and it went down to 28.3, significant. And notice that the pressure of hydrogen went from 102 to 68, which is a lot, but not as much. That's because the hydrogen went from a 5 to 7.5 volume, which is a ratio of 5 over 7.5. And you will discover that ratio times the pascals of the hydrogen is indeed the same answer. Whereas the nitrogen went from a 2.5 ratio and ended up in a 7.5 liter volume. And you can see that ratio is 1 to 3, which means if I took my initial pressure of nitrogen and divided it by 3, it would get the same answer here as 28.3. So you can see that when the volume went up 3 times, the pressure went down a third, or divided by 3. There will always be that direct relationship. The second addendum, we can use Dalton's law for this system because at that time, once we figure the partial pressures, the volume is now 7.5. So it's easier to figure out when the volumes are the same. However, since Dalton's law right here is equal to P1 plus P2, and going back to this, we discovered that P1 was the volume for hydrogen, and we discovered that P1 was equal to the old volume, or the old pressure, times the old volume, 5.0 liters, divided by the new volume. Well, that means we can replace P1 in this equation with this. Okay. So that is now the same as P1. And of course, we're adding it to the P2 that was nitrogen. And the nitrogen we discovered was the old pressure times the old volume divided by the new volume, which is this. Which means I could have rewritten Dalton's law as the total pressure of the system being equal to these two things. Also notice that they now have the same denominator, so I can write it all over 7.5 like adding fractions. So it's really this plus this. Also notice that the liters cancel. So really we're getting ratios, right? So that is also a way to figure it out. So we could have just jumped straight to this if we needed to, if they just wanted to know the total pressure. It's essentially the partial pressure of the hydrogen and the partial pressure of the nitrogen. So there are formulas like that where you just write it like this instead of working it out slowly. That's just a point I wanted to make. Also notice you can always find that relationship between pressure and volume, and you should always check your values based on that knowledge.